graphing lines using the slope-intercept form. So in order to do that, we are going to be given an equation. And the first thing we want to know is, well, has it been solved for y? And our equation has been solved for y. Y is all by itself. This is y in terms of x. So the first thing we need to know, well, what is the slope? Well, if our slope-intercept formula is y equals mx plus b, whatever the coefficient of x is, that's our slope. So our slope for this line is 1/4. Remember from previous lessons that slope is the steepness of the line, or in terms of a ratio, it's rise over run. So our line is going to have a positive slope of 1/4. This will be an increasing function. Next, we want to know the y-intercept. The y-intercept is the constant, or the b value. In this case, it is -3. So the y-intercept is -3, or you can think of it as the point, 0, -3. So since our slope is 1/4, it is positive, our function will be increasing. Let's graph it. So first, solve for y. Second, find the slope. Next, find the y-intercept and plot it. Remember, this is the y-axis, and this is where we're going to start our graphing. And now we can rise and run from that point. Up 1/4. 1, 2, 3, 4. Up 1/4. 1, 2, 3, 4. Plot those points, and that is our line. Now, since our slope is 1/4, that is not a very steep line. It is increasing, but not very quickly. That is what our graph looks like. Yes, linear functions are continuous. So we should be connecting the points to make the line, and it should also have arrows on the end. So that's the line y equals 1/4 x minus 3. Let's do it again, and let's speed up the process. First, has it been solved for y? Yes. Next, what's the slope? The slope is -2. -2, which is the same as -2/1. So we'll be going down 2, forward 1 when we graph the line. Next, what's the y-intercept? The y-intercept is 5. So b equals 5. You can write it like that, or you can say the line will pass through the y-axis at 0, 5. Plot that point over 0, up 5. From there, we're going to rise and run according to our slope ratio. Down 2, forward 1. Down 2, forward 1. Down 2, forward 1. Because our slope is negative, this continuous function will be decreasing. Remember, decreasing functions are falling from the left to the right. So here is what our function looks like. Continuous function, it has arrows on the end. Next, graph the line 3x plus 2y equals 10. Have we solved for y? No. First thing we need to do is solve for y. In order to do that, use inverse operations to get the y by itself. We learned this in a previous lesson. So we got to get the y by itself, so the first thing I'm going to do is subtract 3x from both sides, and that will give us 2y equals -3x plus 10. Next, in order to get the y by itself, we need to undo times 2. We will do that with division. Divide by 2, divide by 2, divide by 2. Every term gets divided by 2. Therefore, y equals negative 3/2 x plus 5. So what's our slope? Our slope is negative 3/2. Our y-intercept is 5. So b equals 5, which would be the same as the point 0, 5. So we are going to go to that y-axis and we are going to plot this point. From there, our slope is negative, so our line should be falling from the left to the right as the function is decreasing. So our slope is down 3, forward 2, 1, 2, 3, forward 2, 1, 2, 3, forward 2, 1, 2, 3, forward 2. So there are some other points on our line. Connect those points and create your continuous decreasing function. And that is what our line looks like. Let's do it again. 5x minus y equals negative 2. Once again, solve for y by using inverse functions. So I will subtract 5x. And remember, this negative is negative 1y. So negative y equals negative 5x minus 2. We're not done yet because negative y means negative 1y. So we need to divide every term by negative 1. So negative y divided by negative 1 is y. Negative 5 divided by negative 1 is positive 5. Negative 2 divided by positive 2 is plus 2. So now we have solved for y in terms of x. Our slope is 5, which is the same as 5 over 1. Our y-intercept is 2. b is equal to 2, which translates to the point 0, 2. Plot the point. Remember, we're always plotting on the y-axis because this is our y-intercept. And then we will rise and run. So rise 5. 1, 2, 3, 4, 5. Run 1. Now, if you're not able to go up any further, remember that positive 5 over positive 1 means exactly the same thing as negative 5 over negative 1. So instead of going up 5 more, we can go down 5, back 1, and be on the same line. 1, 2, 3, 4, 5, back 1. Still on the same line. Our line has a nice, consistent, steep slope of 5. Our function is increasing at a rate of up 5 over 1. We have graphed the line. Last examples on this last page, just a quick reminder of how to graph very special lines. So look at this first equation, y equals 4. So is it possible to rewrite this equation in slope-intercept form? Slope-intercept form being y equals mx plus b. Well, if we have a y, we are able to do that. This would change to y equals 0x plus 4. So if y equals 0x plus 4, if we add 0, we don't change the value. So this is possible. So our slope would be 0 or 0 over 1, and our y-intercept here would be 4, which is the point 0, 4. So if we graph this, over 0, up 4, what type of line has 0 rise? Rise 0, run 1. Rise 0, run 1. Rise 0, run 1. Rise 0, run 1. We are looking at a horizontal line. y equals 4 is a horizontal line where every single point on the line is 4 units above the x-axis. Y equals 4 is a horizontal line. So is it possible to write a horizontal line in slope-intercept form? Yes. But what about our next line? X equals -6. Is it possible to write x equals -6 in the form y equals mx plus b? That's a no. This is a special line. This is a vertical line. And we have already discussed how a vertical line only rises. It never runs. So if it only rises and never runs, it's a vertical line, and a vertical line has an undefined slope. So is it possible to put it in y equals mx plus b form? No, it is not. All we can do is graph it. Let's think about it in terms of an xy chart. In terms of an xy chart, we're told specifically that x is -6, and that's it. So x is limited to -6, which you can see here if the x value repeats itself over and over and over, it's not a function. So x is -6. There are no restrictions on the y-coordinates. So it could be 0, it could be 2, it could be -7. So when I graph these points, back 6, up 0, back 6, up 2, back 6, down 7, we see a vertical line which has an undefined slope because we cannot divide by 0. But what we do see here is every single point on this line has an x-coordinate at -6. The domain of this relation is restricted to being -6. -6 maps to every single possible y value. So, can we rewrite a horizontal line in slope-intercept form? Yes. Can we rewrite a vertical line in slope-intercept form? No. So that is graphing lines.